You've probably heard that in our digital world, data is the new oil. It's a great line. But have you ever stopped to think about who actually builds the refineries? Who lays the pipelines to make all that raw data useful? Well, today we're diving into the world of the data engineer, the real, unsung architects of the information age.
I mean, think about it. Every single click you make, every purchase, every social media post, it all generates data. We're not just talking about a little stream of information here. We're talking about a massive, ever-expanding ocean of it. And buried inside is the key to some absolutely incredible insights and innovations.
But here's the catch, and it's a big one. Just having a ton of data doesn't mean you have useful data. Imagine trying to build a house, but your supplies are just a random pile of mismatched bricks, warped wood, and screws of all different sizes. That's exactly what raw data is like. It's chaotic, it's inconsistent, and it's scattered all over the place.
So that leads to the million-dollar question, right? How in the world do you take all of that chaotic information and build something an entire organization can actually rely on? You know, a foundation that's structured, trustworthy, and secure enough for their most critical decisions.
Well, this is where the architect comes into the picture. The solution to this mess isn't some kind of magic trick. It's just really, really smart engineering. So let's meet the master builder of the data world, the data engineer.
So here's the key takeaway. While other people, like data scientists, are the ones analyzing the data engineer is the one who designs and builds the entire system that makes any of that analysis possible in the first place. They create the infrastructure, the pipelines, literally the foundation everything else is built on.
You know, a really great way to think about this is to imagine a library. The data engineer is the architect who designs the building itself, and also the librarian who carefully organizes all the shelves, making sure every book is in perfect condition and easy to find. The data scientist, then, is the researcher who comes into that beautiful library to read the books, connect ideas, and uncover brand new stories. You see? They absolutely need each other to succeed.
All right, so what does one of these data architects' blueprints actually look like in their day-to-day work? Let's break down their core responsibilities.
So their work really stands on four main pillars. First up is architecture. They're the ones designing the foundational structure, kind of like the floor plan for a building. The second is something called the ETL process. This is huge. It means extracting raw data from all over the place, transforming it by cleaning and organizing it, and then loading it into one central, easy-to-use warehouse. Third, you've got data governance. Here, they act like guardians, making sure the data is accurate, secure, and being used responsibly. And finally, collaboration. Data engineers don't work in a vacuum. They're constantly talking with scientists and analysts to really understand what they need and then deliver it.
Now, to build all of this amazing stuff, an architect needs some serious tools, and a data engineer is no different. Their toolbox is absolutely packed with powerful programming languages, stored solutions, and processing frameworks.
Okay, first up, let's talk programming languages. Python is a huge favorite, mostly because it's so readable. It's almost like plain English, but it also has these incredibly powerful libraries for data tasks. Then you have Java. Java is the industrial strength workhorse. It's built for those massive, super complex systems you find in big corporations. And then there's Scala, which is often paired up with a framework called Apache Spark to process just enormous amounts of data in pretty much real time.
So where do they actually put all this data? Well, think of it this way. A traditional SQL database is like a perfectly organized filing cabinet. Everything has a specific folder, a specific label. A NoSQL database is more like a big old duffel bag where you can just toss in items of all shapes and sizes, way more flexible. And a data lake? It's exactly what it sounds like. A vast, massive reservoir where you can pour unbelievable quantities of raw data of every kind imaginable.
And how do they manage the constant flow of all this data? That's where these processing frameworks are absolutely critical. Apache Spark is the speed demon. It's amazing for things like analyzing live streaming data that has to be done right now. Hadoop is more like the reliable heavy-duty truck, perfect for processing huge batches of data overnight. And then a tool like Apache Airflow is the conductor of the whole orchestra, scheduling and watching over all the different data pipelines to make sure everything runs perfectly. Okay, so we've seen the blueprint, we've looked inside the toolbox, but how do you actually go from understanding all this in theory to building a real career in this field?
It really comes down to this: mastering this toolkit, the languages, the storage solutions, the frameworks. That is the key. It's what makes you not just effective in the role, but frankly incredibly valuable to companies who are absolutely desperate for people with these skills.
But please, remember this last, most important piece of the puzzle. Knowing the theory and getting good with the tools, that's step one. That's essential. But what will truly, truly set you apart is your ability to take all that knowledge and apply it to solve actual, real-world problems. That's the magic step that transforms you from a student into a genuine engineer.
You know, almost every single innovation we see today, from advanced AI to personalized medicine, it all rests on a foundation of clean, reliable, accessible data. The world doesn't just need more data. It needs more architects who know how to shape it. So the only question left is, are you ready to start building?